Welcome everybody to another walk through this demo. So it is a dam with water that is being blocked by this dam, and the dam fall apart, so the water rush through the valley that you can see here. If we go through, boom, and still rendering in redshift. See the flare. This is supposed to process by redshift on the render, and the glow and the strikes, as you can see here. Okay, so just go through the file and see how we did it. It's simple, straightforward, nothing too complicated, hopefully. So we have couple of cameras here. These are the camera. Let's label them pink, and we have dome light, and I'm still rendering in redshift. So this is the sequence. This is the previous simulation being cached. Anyway, so this is the geometry. Shift O will make this what we call it, box, network box, and if you press on it and label on the color, it will change. So let's start here with a tube. So I started with a tube, as you can see. Then I make some extrusion, this amount with output of the back. Then I choose by group using a bounding box, and I choose this area to be the active area that will fracture. Then I make split, so this is the area, and as you can see it is open. So I did polyfill for this side and for the remaining side, as you can see here, polyfill. I remove the group, I call it active dam. I scatter 3000 point, and I use Voronoi fracture to create the concrete fractures, and I call it B dam. On the other side I did the same thing, but less points, so they can be joined together, because if you keep it as one piece, it will be like a closed object, so it will not simulate well with the rest, so that the other fragments will fall on the roof here. That's why I fracture it, so it will have a convex shape. So after that I added RBD constraint from rule, and I call it dam active con. As you can see, it captured all of it. Then I added this node, I call it it's called RBD constraint property, and I choose that constraint and I make it a glue, and it's very weak glue. Then I back it so I can merge it with the rest. Here I didn't add any constraint because this will be inactive, and I created a group, I call it passive dam, that I will use it here down below in the RBD config. After the merge, as you can see, it's backed. I unback it, another RBD constraint from rule, and this time I choose from group to group. I use the dam to connect to the passive. So as you can see, this is the area where the connection will be, and I created, let's give it a color of pink. So this is the connection and this connection I made them -1. -1 mean it will never break. Then in the RBD config I selected the groups here. I selected all this area and I make it inactive. Active. This is for visualization. So as you can see, the black will not be simulated, but it will affect the active pieces. So this area will fall apart. I have a sphere. This template, this one. I transform it, give it some mountain, and I merge it with the terrain, piece or part of the terrain. As you can see, let's play it. So this is the fracturing animation or simulation. Another look. So this is how the fragments will fall. Let's have another view from down below. Cool. After that I unback it and made a collision from source or collision source. So I have a volume and a geometry that will be added in the flip simulation. So this is the VDB. I make it 0.05. You can see. Let's go here. These are the parts, so it will affect the water. Now in the other part we created small height field. So this is the dam. The height field is 100 by 70. So this is where the river. So height field. Then I painted where the river will be according to the dam. So this is the painting. So these small islands where water will collide also. Then I made little blur, as you can see, without width, so we don't have sharp edges, and I inverted the mask. So whatever operation I will do, like noise or elevation, it will be in this area. So I added height field noise, see, and I make sure mask area is the mask. You choose the mask, and because we inverted, so it's working. So this is the river, these are the small islands. I remove the mask and I use height field mask by feature. So this one will select for me according to the slope, to the ramp, to the occlusion, direction, whatever you choose, and you can modify it, the range. So I selected all these edges, so it created this mask that I use it by connecting the mask area. See, mask, this is the geometry, this is the mask, and I added more noise using that mask, but very tiny. I clear the mask, then I run through height field erode. So erosion will make it smooth, will create some hydro and thermal and curve and waterfall and rock bed, all this area. After you select it, you choose your setting, trial and error, and you run it. And when you like one frame, let's say frame 7, you'll put here frame 7 and you put freeze. After that I added a convert, because this is just a volume. These are volume, see, 6 volume, and we want to have polygon and get rid of the volume. So convert height field, and let's run here. Convert height field, added collision source, but in the height field I did extrude base, so it's automatically extruded. Okay, same operation, collision source. I have the geometry out and the height field. UV, subdivide, and added a basic megascan material. One thing I want to talk about, let's go here. Inside the solver, if you put the sub solver, you have this one, sub solver constraint geometry. Subsolver constraint geometry. So this one, if you connect it, let's say here, you go inside, so you have the constraint, and you can add any operation to the constraint directly. So it's new in Houdini 19. You can do multiple operation here. So it's compiled. Here I took another branch from the tube, I fill it and make it a little bit lower so the water won't spill out, and I export it. Here I'm just importing the dam pieces and applying material to the outside. Let's do the plast. I can show you plast. If I choose inside, so I have the inside geometry. So this I applied darker material, and this one is the outside. I make it lighter, see. Already automatically generated by the Voronoi fracture. Now here what did I do here? Yeah, here is the fluid part. So the water object is using that null that we talked about here, that we branch out this one. So it's referencing this one, null 15. Okay, in the fluid solver. No, before that, here I make it 0.03 for the simulation resolution. Here I added divergence and verticity, droplet, but I didn't use, and receding by default. And I added the other static object. So this one is the collision that we branch here. Selected. Where we branch it? This one, the VDB. So here using volume collision. This one is for the Tiran. I use height field, okay, and I'm referencing this branch that we took. Before we convert it to polygon. That's the one. The second one, volume sample, and we are using that VDB that we used here. And this is the simulation. Let's run it. So water is flowing and colliding with the surface and colliding with the fragments, crushing here, crushing wave, and it's flowing. And this is another view. The camera need to be fixed. Okay, anyway, so while running this simulation, it will be imported here, it will be compressed, cached, and after that it will go through the particle fluid surfacing. I added dilate, smoothing and erosion, and final smoothing and surfacing. I make the voxel 255, should be 55, okay, 255, very low. And here is the interior. This will be imported automatically. I make it a volume VDB from polygon, and I make it fog, not distant field 0.05, that I give it a volume material. Then here is the sourcing. Sourcing is according to the curvature of the fluid, to the acceleration color and the verticity that we activated in the flip solver, and this is how it look. That is being used to generate the white water according to the depth. Below water surface, or the water surface, it will be bubble. On the water surface or zero, it will be foam. Outside the water surface, it will be considered as spray. So we have it here. This one we out to the white simulation, and here the most important thing, we added stat attribute. So we have the foam, bubble and spray, and we make erosion for the foam also. After we run the simulation, we import it here. I'll show you here how it will look. So if we take this example, below water surface is the bubble, the blue one is here. I make the blue RGB blue bubble. On the water surface or zero level will be considered as foam, so it's green. and outside the water surface is the spray particle. One thing I did in the white water, in the emission, I make bubble life and aging high and the spray is low, so the bubble and foam don't last for, and I make the velocity offset of 0.5, so we have more spray particle. So it will be rendered as a volume. Here I blasted out anything spray above 0.2. I'm removing the rest and I'm keeping the spray and adding point replication with some noise and stretching up to 2, so we have increased number of the particle. If I put here, see, it's more. In the material, so in the redshift material, this is the inside, darker color with some noise to the bump. The outside just standard material, gray color, and the Tehran, I didn't use this one, I used this one. It is Quixel triplanar material with some displacement. For the white water, I use a volume with some higher density, so it will look bright. This is the interior with some tinting to the blue color, and this is just the water preset, but I removed the dispersion, and this is how it will look like up to now. Thank you very much. Have a nice day.